Let's take a closer look at atoms. Atoms are the building blocks that make up everything, all stuff, everywhere. Here I've got some drawings. This is table salt, a solid. Here's water, a liquid. And finally, oxygen gas. And what we're looking at here is what we'd see if we could take these three things and zoom in zillions and zillions and zillions of times. And if we could look at these closely enough, we'd be able to see the atoms, these little building blocks that make everything up. Now, atoms aren't really little colored circles, but it's a good way to think about them, and it's the way we'll usually draw them when we're learning about this stuff. Atoms are super tiny. They are so tiny, it can be really hard to wrap your head around how tiny they are. Here is something that might help you think about this. Take a piece of paper. Look at how wide it is here, all right? This is so incredibly thin. Now, atoms are so small that it would take 1 million atoms lined up next to each other in a row to be as thick as this tiny width of paper. That's how small atoms are. Now, what I want to do now is look even closer at an atom. Let's take one of these atoms here and zoom in even more so we can see what's inside of it. Here's a magnified view of one atom. It's not a perfect representation of exactly what an atom would look like, but it's close enough for right now. And check this out. The atom itself is made up of even smaller things. Right, so that we said atoms are like the building block for all of stuff. But then if you look at an atom, it has even smaller building blocks that make it up. So in the center of the atom is something called the nucleus. And the nucleus is made up of two tiny particles. There are protons, which I've drawn as red circles here, and then there are neutrons, which I've drawn as blue circles. Nucleus is here in the middle of the atom. And then on the outside of the atom, there are these little black circles that I'm using to represent electrons. The electrons, you'll see, are connected to these sort of oval paths, and I've drawn these in to show that the electrons are constantly moving. They're flying around the outside of the atom at an incredibly high speed, whereas the nucleus stays solid here right in the middle of the atom. Now, electric charge is very important when we're talking about atoms for a number of reasons. Protons have a positive charge. A proton has a charge of 1 plus. Electrons, on the other hand, have a negative charge. One electron has a charge of 1 minus. Now, neutrons, they don't have an electric charge at all. They have a charge of 0. And neutral is a word that we use to refer to something that doesn't have a charge. So neutrons sounds a lot like neutral. Now, positive and negative charges attract. Remember that? Opposite charges attract. And that has important consequences for how this atom works. We said that these electrons are flying around the outside of the atom. They're moving really fast. So why don't they just fly out into space? Well, the reason why is because the negatively charged electrons are attracted to the positively charged protons. So the protons kind of pull the electrons in. They keep them from just flying away. But the electrons are moving around so fast that they're not able to actually pull in here and actually touch the protons. So that's why they keep staying on the outside and don't just crash in here and all touch the protons. Now, sometimes people ask, well, neutrons don't have a charge. Why are they important at all? Here's a diagram of an atom. It's not perfectly accurate, but for what we need right now, it's going to do just fine. So in this lesson, we're going to look at characteristics that we can use to describe atoms like this one. You know, if somebody asked you to describe a person, chances are you'd use characteristics like the color of their hair, the color of their eyes, what their height is, and so forth. Just like that, there are characteristics we can use to describe atoms. The first of these characteristics, and maybe the most important, is the atomic number. The atomic number is often abbreviated by a capital letter Z. And what the atomic number is it's the number of protons in the nucleus of an atom. In my diagram here, I'm using these red circles to represent protons. So I have 1, 2, 3 protons in this atom. So the atomic number is going to be 3 for this atom here. Atomic number is particularly important because the number of protons in an atom tell us what kind of an atom it is. And by that I mean, is it a carbon atom? Is it an oxygen atom? Is it a sodium atom? We're going to talk more about that in the video on isotopes, so you don't have to worry about it for right now. The next important characteristic that we can use when describing atoms is the mass number, often abbreviated by an uppercase A here. Mass number is the number of protons plus the number of neutrons in the nucleus of an atom. People always get confused by mass number. Here's why. Atomic number is the number of protons. So everybody always wants mass number to be the number of neutrons, but it's not. It's the number of protons and neutrons. In fact, there's not really a name for the number of neutrons, just the number of neutrons in an atom. We just don't use it that often. So anyway, for mass number, we want to count all of these together. 1, 2, 3, 4, 5, 6, 7. The mass number of our atom here is going to be 7. Now finally, the third characteristic we're going to talk about here is probably the most complex, and that's called net charge. I don't have a good way to define net charge. I don't have a good definition. So what I'm going to say here is it's how protons and electrons balance each other out. Let's talk a little bit more about this. So net charge is about how protons and electrons balance each other out. So protons, as you know, have a positive charge, and electrons have a negative charge. So that means that if we have the same number of protons and electrons in an atom, like I have right here, 3 protons and 3 electrons. I'm not drawing the neutrons here because we're not worried about them. Here we have the same number of protons and electrons. They're going to balance each other out. This 3 minus is going to balance out the 3 positive. So we're going to end up with an atom that has a net charge of 0 because these two things balance out, and we can call this atom neutral, which means that it has no net charge. Now, what would happen in an atom where we have 4 protons and 3 electrons? We don't have the same number of electrons and protons anymore, so they can't totally balance each other out. Instead, we have more protons than electrons, so that we're going to have a net charge that's positive, because there's going to be some of this positive charge in the protons that can't be balanced out by the electrons. In this case, we have 1 more proton than electron. So this is going to give us a net charge of +1. Since our atom has a net charge, we give it a special name. We call it an ion. An ion is any atom that has a net charge. Neutral is what you call it if you don't have a charge. Ion is what you call it if you have any charge. Okay, this is where we have 1 more proton than electron. What about this case here? What if we had 5 protons and 3 electrons? In this case, the charges don't balance out either, but now I have 2 more protons than electrons. I've got 2 more protons that aren't getting balanced out by these electrons. So that means that I'm going to have a net charge of 2+ for these 2 protons. And again, this is going to be an ion because it's got a charge. Now the opposite can happen as well. Here is an example where an atom has 4 electrons and 3 protons. So now it's got more electrons and protons. These 3 protons can only balance out 3 of the electrons, so I have 1 more electron that's not getting balanced out. That means that this total charge is going to be -1. That's a charge of this 1 more electron that I have in the proton. Here's an atom. What's the atomic number, the mass number, and net charge of this atom? So atomic number is the number of protons. In this diagram, these little red circles are representing protons here in the nucleus. So I've got 1, 2, 3, 4, 5, which means that my atomic number is 5. That was easy enough. Mass number is the number of protons plus the number of neutrons, which are these things in blue. So the mass number is 1, 2, 3, 4, 5, 6, 7, 8 protons plus neutrons. So mass number is 8. Sometimes people think you have to have the same number of protons and neutrons in the nucleus of an atom. Definitely not true. They can differ quite a bit. The net charge is how the protons and electrons balance each other out. So, electrons are represented by these things here flying around the outside of the atom. 1, 2, 3, 4. 4 electrons, E minus is a way that we can abbreviate electron, and 1, 2, 3, 4, 5 P plus protons. So, the protons and electrons don't quite balance out. There is one more proton than electron. So that one extra proton is going to give me a net charge of 1 plus, because each proton has a positive charge. I have one extra proton. Net charge of 1 plus. This is kind of a basic problem. Now we'll move on to stuff that's a little trickier. So here we've got an atom with this atomic number, this mass number, and net charge. From this information, we need to figure out the protons, neutrons, and electrons that are in this atom. Protons, that is going to be easy because protons, number of protons, is the same thing as atomic number, so that's going to be 7. Now what about neutrons? Mass number is protons plus neutrons. So this 15 here is protons and neutrons together. I already know how many protons there are, so I can do protons plus neutrons, the mass number, minus the number of protons equals 8, the number of neutrons. Net charge here is plus 2. If I have a positive net charge with a certain number, that's telling me how many more protons I have than electrons. So in this case, net charge of plus 2, there are 2 more protons than electrons. Since I have 7 protons, that means that I have to have 5 electrons for me to get a 2 plus charge. Here's a table with various characteristics of a certain atom. We need to fill in the things that are empty. Okay, we don't know how many protons, we don't know how many neutrons. Where can we start? Okay, we know the electrons and we know the net charge. So based on the number of electrons and the net charge that this atom has, we can figure out how many protons there are. Okay, since this is a net charge of minus 3, that means that there are 3 more electrons than protons, because electrons have a negative charge. So I have 7 electrons. That means that I'm going to have, if I have 10 electrons, that means that I'm going to have 7 protons. 3 more electrons will give me minus 3. Okay, now I know that my atomic number is the same as my number of protons, so that is also going to be 7. The mass number here is the number of protons plus the number of neutrons. So to get just the number of neutrons, I take the mass number, protons plus neutrons, minus the number of protons, 7, and that is going to give me 9 neutrons. Sometimes these table problems can be the hardest, so we'll do one more example. Here we want to find the electrons, protons, and the atomic number. We know the neutrons, the mass number, and the net charge.